All right, we're back. We're on page 171. We're talking about conic sections. We just talked about circles, which have an eccentricity of 0. We're going to talk about ellipses now, which have an eccentricity somewhere between 0 and 1. So let's say, what's the definition of an ellipse, right? So definition of an ellipse is the set of all points in the plane. So the definition of a circle is a set of all points in a plane, a fixed distance from a particular point, right? This is the set of all points in the plane, the sum of whose distances. So the sum of whose distances from two fixed points. So those are called the foci, is a constant. So the sum of the distances from two fixed points is a constant. So I actually found, I mentioned at some point that I could swear I had made a lot of stuff on GeoGebra, and it turns out that I did. And searching for your own things that you've made on GeoGebra is really hard, and that's a problem for me in general. So I actually put together this thing. It's for all of Notes 14, and it's got a bunch of things. So like getting started, we have cone intersecting planes, and you can like play around with it and see the intersection points, and you can move this. So yeah, like go play with it if you want. Like here's a hyperbola. So it's so disappointing that I didn't have this when we were doing this. Here's a parabola, and then here's a randomly slanted thing is going to give us an ellipse. So there's that. Then I had recreated the eccentricity thing, and I kind of made it better. It tells you what it is, and then you get to here, and it's a parabola, and then it's a hyperbola, and blah blah blah. All right, so spent all the time making them, so I thought I should show you. I linked this on my website underneath the notes, or if you go to this URL, so it's geogebra.org/m/vyhhauer. I don't know, it's probably easier to go to the website. Maybe if I remember, I'll link it in the description, but I doubt that. All right, so I'm gonna click on definitions. Ellipse, sum of distances from foci. So is this big enough? Like probably not, maybe not. But here are the two foci. So here's a focus, here's a focus. They're inside the ellipse. Now the definition is it's the set of all points in the plane, the sum of whose distances from two fixed points. So the two fixed points are the foci, the sum of the distance. So this distance plus this distance. So here I'm calculating, what am I calculating? Oh, I'm showing each individual distance, like right now they're the same, and then I add them up and I get 7.62 in this case. Now let's move the point. So look, the distances are changing. Like right now, the distance from the point to F1 is 6.2, and from the point to F2 is 1.42, but it still adds up to 7.62. That's the key thing. They're always going to add up to 7.62. And actually, what's going to happen is we're going to use this point, right? When I'm exactly across, when I'm on the same line as the foci. I can use that to figure out something a little geometric about this, which we'll do at some point. But in this particular ellipse, it's always adding up to 7.62. If I resize the ellipse, let's do this. So now they add up to 9.71. They will always add up to 9.71. So one way that I like to think about it is like, if this is like, say you have a goat, for example, and you chain the goat using like, you have two pegs in the ground and then a chain that goes like up through like a loop in its like a collar, I guess, and then back down to this. And then this, the ellipse, is just the region that he can eat everything. So the goat can eat anywhere inside there, but the farthest he can always go is going to be on this ellipse. So that's the definition. It's the set of all points of the plane, the sum of whose distances from two fixed points is a constant. And so we need to know, like, what is that constant? What else can we do? So let's go back and learn an overwhelming amount of stuff about an ellipse, all in this one page of notes. So here we go. First of all, the standard form of an ellipse looks kind of like a circle, except if it was a circle, like this would be r squared and these would both be 1. But then if you divided, you would get x minus h squared over r squared, y minus k squared over r squared equals 1. So is a circle an ellipse? Not by our definition, but by like every reasonable thought process other than the definition, yes. But anyway, So we have x minus h squared over a squared plus y minus k squared over b squared equals 1. A has to be bigger than b. So initially it's a lot to take in. This will have a horizontal major axis. Major means it's kind of like fatter in that direction. So this is fat in the x direction and then skinny in the y direction, as opposed to a vertical major axis. So major means the bigger axis. So the bigger axis is vertical in this case. So it's fat in the y direction. Now A is bigger than B, which means if you look for the bigger number, because if you square a bigger number, it gets even bigger. If you look for the bigger number in the denominator, it's telling you which way this thing is fat. So if the bigger number is under x, it's fat in the x direction. If the bigger number is under y, it's going to be fat in the y direction. That's literally how I remember this. Now let's figure out what A, B, and something called C are going to be. So you have a center. So the center is HK, which is good because that's just like a circle. So the center is HK. The distance from the center to a vertex. Holy cow, I overshot that. You know what, let me just do this and then I'll move it. So I'm gonna do this and then I'm gonna move it because I can do that. I'm gonna say this is A. So the center to the vertex is A. So this is a vertex. V1 and V2 are called vertices. V1, V2, vertex, which vertices is the plural, but V1 and V2 are vertices, vertex. F1, F2 are the foci, F-O-C-I. Each one is a focus. And the distance, so CV1 and CV2, man, so much stuff. Those are covertices, covertex. All right, so the center is HK. So then this point right here is going to be H plus A, comma, K, for example. And then this point over here is going to be H minus A, comma, K. The distance from the center to the covertex is B. So I'm going to do the same thing, right sheet. Be that, and then there. And then I will pick you up and move you to where it's convenient. So this distance is B. So the distance from the center to a vertex is A. That's the bigger distance. The distance from the center to a covertex is B. There's one more distance involved, and that is called C, and that is the distance from the center to a focus. I will use blue for that because it's already kind of blue. Why? You gotta like remember what you're doing when you do this. So this distance is going to be C. So I think that'll get it all. Does it? Nope. Or I don't know. I think I had like my hand on it. There we go. Okay. So this distance is C. So from center to vertex is A, from center to covertex is B, from center to focus is C. Okay, so that's a lot. But it means like, you know, it's not hard to work things out. It's like a very kind of algorithmic process, right? So this is H kind of K plus B, and then this would be H comma K minus B. And then this focus, for example, would be H minus C comma K, and this focus would be H plus C comma K. Okay, so for an ellipse, so you're going to memorize this. In every ellipse, C squared equals A squared minus B squared. So the interesting thing is that B doesn't exist really. It's A and C are what really exist. But if you want to see where these equations come from, I have a separate video where I go through and actually like derive the equations using the calculator. It's a pretty long video. I think it's in the other playlist. So I'm not going to put it in this playlist. Maybe if I remember, I'll put it in the description, but I doubt it. But if you want it and I didn't put it, I don't know, leave a comment or something. Let's look at how the vertical, so major axis, what's major axis, minor axis? So major axis is going to be here. This is major. Oh boy. Major axis. And so the major axis is going to be 2a units long. The foci are on the major axis. The minor axis, I'm going to use a different color, I guess. Look how unsteady my hand is. This is the minor axis, and that's going to be 2b. So the major axis is 2a, the minor axis is 2b. The vertices are a away, the covertices are b away. The center is in the middle, obviously. The foci are c from the center. There's a lot of information. The bigger number is telling you which way it's fat. So if the bigger number is under x, fat in the x direction. If the bigger number is under y, it's fat in the y direction. So let's see over here what we got. It's basically the same idea. So this is going to be b because it's the distance from a center to a covertex. That's b. The distance from the center to a vertex is a. So this will be a. So that's from the center to a vertex. And then from the center to the focus is c. You know, actually, there's another video of me doing all of this. I'm just doing it like not as live, like I work everything out ahead of time. You may choose to watch that instead. And again, c squared equals a squared minus b squared. So in this case, we have a bunch of information, right? We have our equation. So you have your equation, which would be x minus h squared over b squared plus. So there's a plus in the equation. And then when you're finding c, there's a minus. So that kind of thing is going to be important because you're looking for patterns. So this equals 1. You got your center is at hk. You got your vertices, in this case, are going to be at h comma k plus or minus a. You got your covertices. That's going to be at h plus or minus b comma k. You have your foci. That's going to be at h comma k plus or minus c. So that's 2, 3, 4, 5. Okay, so there's 7 things that you need to know. The 6th thing is the eccentricity. Eccentricity is always c divided by a. So you memorize it for a circle, you memorize it for a parabola. Circle is 0, parabola is 1. Eccentricity of an ellipse or a hyperbola is c over a. And then the 7th thing that you're going to know for these is the area. And the area is crazy. It's pi times a times b. So why is that crazy? That's crazy because what would a and b be? What would be the values of a and b if this was a circle? If this was a circle, you would go an equal distance from the center to here and the center to here. So a and b would both be r. And then the area would be pi times r, which is pi r squared, which is the area of a circle. Circles should be ellipses. They're just not for some reason. So let's see. Let's see if we missed anything. Major axis is where it's fat, 2a. Endpoints are called the vertices. Obviously, a is half of that. The minor axis is the skinny part. It's 2b, and it ends in the covertices. The center is hk. It's the midpoint of like every line of symmetry. The foci are always c units along the major axis. So they're on the same axis as the vertices. The standard equation is going to have a 1, right? So it's going to be equal to 1. That's kind of like a thing, except for circles, pretty much. The equation has a plus, and the formula for c is a minus. The area is pi ab, and then c over a. So 7 things that you want to find. Here are the 7 for the vertical major axis. It's the same 7 things for horizontal. It's just that you would, get different values, obviously. I encourage you to use the plus or minus. I'm going to do some practice problems where I'm using it. Always use plus or minus. It's just so annoying when you don't. I mean, I'm confident that you can add and subtract something. So like, I'm not worried about that. But anyway, let's get out of here. And then we will do some, so there's 7 things. Let me just highlight this because I just noticed it. 7 things: equation, center, vertices, covertices, foci, eccentricity, and area. When you were told to find everything, that's everything for an ellipse. So I'm going to end this video. I'll come back and actually do some problems, and I will see you there.